Again, P union R is the second question, which would be a combination of 1, 2, 3, 4, 6, 8, 12, 16, and 24. That is P union R. And then we talk about Q union R. Q union R would be Q combination of R, which is 3, 4, 6, 8, 9, 12, 16, 15, 18. Right? Another one is the union of P, Q, and R. That would be the entire thing. Just make sure not to repeat it because that's right. And then they want us to draw a Venn diagram to represent the set of PQR. So we draw a total set. And I'll show you how to shape. Right. So PQR. If we look at that just now, we have 1, 2, 24, 3, 6, 12, 9, 15, 18, and then here's 16, right? So we want the union of P and Q. So the answer would be this, right? So that's the shaded part. The next question is intersection between union of P, Q, and R, which is the entire thing then, because it's a combination of everything. So that is why we don't actually duplicate the numbers, even though it exists in different sets, because it just shows the intersection, right? Next one is the limit of 50 to 60, and then G is a prime number, Gx is a prime number, and set H, X is a multiple of 4, I multiple of 5. These are the elements, and okay, so this is the complement of union. So notice that we have complements of intersection. We also have complements for union, which also means the opposite of the union, basically. So anything except the union, right? So let's try this. We'll list down so the overall limit is between 50 and 60. So set G would be the prime number, right? So 53, 59. Set H, multiple of 4, which would be 52, 56, and 60. Because our limit is between 50 and 60, right? And I would be 50, 55, and 60, right? So we want the complements of union of G and H. So union G and H is 52, 53, 56, 59, and 60. So we want anything except the complement, except the union of G and H, which would be 50, 51, 54, 55, 57, and 58. So the number of elements, the number of complements I have here, oops, understand that the symbol is this and not this, okay? The number of elements I have is 6, right? Similarly for the rest. We'll skip to question D then. So the union of GHI, G union H union I, as we can see, is 50, 52, 53, 55, 56, 59, and 60. Right? And we want the complements of G, H, and I union. be any number except this, right? So let's check again. What number are we missing? So 51 would be 54, 57, and 58. So again, the number of elements of complements we have for the union function set would be 4. Okay. So this is also a visual aid to help you understand the complements of union. I will be attaching this slide into the bio below, so you can actually assess it. So the problem solving of union done, we'll skip right to it. A total of 26 pupils participated in the scouting program at the river bank. The activities program are kayaking and fishing. 18 people participated in kayaking, 15 pupils participated in fishing, while 9 pupils participated in both kayaking and fishing. What is the total number of pupils who participate in the program of the following program? Okay, so we understand that 9 pupils participated in both. So again, you will use the Venn diagram for visualization. 9 would be here. So that's the people that participate in kayaking and fishing, right? And then we understand that there is 18 pupils that join kayaking, which means that only kayaking would be 18 minus by 9, which is 9, right? And then F, which is fishing, the total number would be 15. So the people that only fished would be 15 minus 9, which is 6. So what is the total number of people who participated in the activities of the program? So we understand that the total number of people that participated in the program would be 24. So how would I come up with that number, right? The total number would be 9 plus 9 plus 6, which is 24, which is the number of people that participated. We understand that 26 pupils participated in the scouting program, but not all joined the kayaking and fishing, which shows that since 24 people participated in kayaking and fishing, 2 people did not. So there you go. Next question is the total of 100 adults were involved in a survey on their top choices of reading materials. 40 people chose newspaper, 25 magazine, 18 storybooks, 8 both newspaper and magazine, 7 both magazines and storybooks, 5 both newspaper and storybooks, 3 all 3 types. So we understand that there is also an intersection between the 3 sets, which is the newspaper, storybooks, and magazine. So with this, we understand that there is an intersection between 3 sets, where we will draw 3 circles then. And the intersection would be 3, because 3 people chose all 3 types. And we have basically storybooks, magazine, and newspaper. So we understand that 5 people chose both newspaper and storybooks. So that means in here there is 5 people. So 5 minus 3, 2. And then we understand that both magazine and storybooks, there are 7 people. Both magazines and storybooks is over here. So 7 minus by 3, which is 4. And then we understand that magazine and newspaper, there are also the combination, which is 8. So which is here would be 8. So what's 8 minus 3 would be 5. Alright, so we want to understand how many people only read magazine only, newspaper only, or storybooks only. We understand that we have the total number, right? So for magazine per se, we have 40 for total. So this would be our unknown variable, which is x. I'll label it as x. So to determine this x, which would be 40, because we understand the total people that read the magazine would be 40. So 40 is equals x plus 5 plus 3 plus 4. So, hold on. Oh, sorry, I took the wrong value. Okay. So magazine would be 25. 25 is over here. See, that's the problem of having a lot of words in the paragraph. Right? So x, if we can get 13. Right? So next is newspaper. Newspaper is the 40. Yeah. So to determine this unknown variable, which is y, we can get y equals to 30, which is 40 minus by 5 minus by 3 minus by 2, which is 10, 40 minus 10, basically. So storybooks, we have 18 people chose storybooks. So this would be our unknown z, and we will get 18 subtracted by 3 minus 2 minus 4, which would be 9. So how many people do not choose any of the reading materials? It's again similar to the last question, but this is, in other words, what is the complement of the union S, M, and N? So in other words, we can get the people that did not choose any reading materials by finding out by adding up the total number of people that chose a reading material. So in other words, the number of people that didn't choose any of the reading materials would be 34, because that would be, we understand that 100 is the total, so 100 minus by 5, 3, 4, 2, 13, and we will get 34. Right? So that's it. Then we'll go into combination. So combination, we understand union and intersection. So right now we'll try to combine our understanding of union and intersection. So it's given that the limit is here. X is a multiple of 3. X is one number such that the sum of the two digits is odd, and set C is that, right? So again, we'll write down everything we need. Again, intersection, the limit is between 30 and 40. So A is the multiple of 3, so we'll be 30, 33, 6, 39. And then B is the number such that the sum of its two digits is odd. Okay? So that would be 30, 33, 36, and 39. What the sum of the two digits is odd? What does it mean? So basically, when you add these two up, which is 3 plus 0 is 3, which is an odd number. Again, alright? 3 plus 6 is 9, which is also an odd number. 3 plus 9. Oh, sorry. It's 38 then. 38. 3 plus 8 would be 11. Alright? So it's good to check again. So okay, and then we'll go next for set C. Set C, we already have the set, so we don't have to actually list it out. So list all the elements of the following sets of A intersect B, the complements of A union B intersects C. So what is the complements of union A and B? Union A and B, the complements would be it's good to list everything out bit by bit so you can understand, you can see it clearly. So the complements of A and B would be 31, 35, 37, and 40, because it's not here, right? Okay, and then what's the other one? C would be set C, and we want the intersection. So we have these two numbers and we want the intersection. Thus it will be 35, 35, and 40. So in a way the answer is 35 and 40, right? Again, we'll do the third question then. So we understand that, okay, so the third question will be tougher, so I'll just do that. So A intersects C, I want the complements of A intersects C. A intersects C. It's also good to list out from the starting, like what is A intersects C, then after that you look for complements of A intersects C. My method is a little bit faster, so you can actually just list it out, so I'll just do that then. A intersects C, we get 30 and 39. So anything other than 30 and 39 would be complements of A intersects C. So that would be 31, 32, 33. Okay, so we have A complements of A intersects C. So then we have B intersects C. What is B intersects C? So we'll just compare B and C again. Just 30 and 32. Whoops. And 32. So they want the union between both of this. They want the union. Right? So this would be, so our final answer would be 30, 31, 32. You might think that that's the order number, but do take note that in this list 39 is not here. So yeah, it's good to be careful to start from the simplest one, like A intersects C, and then what is the complements of A intersects C, and then we'll go from there. So draw a Venn diagram to shade the region that represents the following sets. Okay, since I didn't do the second one for A2, I'll just draw it for B2 then. So okay, we'll just list out all the values again first. Okay, oops. We have that now, so we'll do question 2 then. So what is A prime? So I want anything except A. So that would be, hold on, let me draw. Okay, so that means I want anything except A, because A prime means I want everything except A, which would be here. Okay, remember that. And then we want B plus C, B union C. B union C would be this then, right? So we want the intersection between A prime, which we drew here just now, and B intersects C. So if we see clearly, this would be the intersection then, and this would be the intersection. Yeah. Right. So that's about it. We'll try question 3 then, just to make it clear. Again, we'll look for the small one. What is A intersects C, the complements of A intersects C? A intersects C is here, so anything except that, right? And then we have B intersects C, which is here. So I'll just change color for. We have A intersects C just now, which is here, and then everything except that. And do take note that this is a union sign. So basically, our answer would be this entire red thing, except here. Oh, that's. So if you look clearly, our answer will be this. Everything outside except just the part that I outlined here just now, except 39. Okay, so that's for representation, visualization. Okay, so we'll do one last question. The residents of Association Happy Garden organizes various sports competitions to instill health awareness among residents. So a total of 35 participants join football competition, 24 table tennis, 13 badminton. There are 4 participants who join football and table tennis, 8 participants who join both table tennis and badminton, 2 that join all 3. There is no participant joining the badminton, no participants in badminton and football. Okay, calculate the total number of participants who join the one competition only. Okay. Alright, then we'll use the Venn diagram again. So let's list this as football, badminton, and table tennis. So we understand that 2 participants join all 3. And then for badminton and football competitions, it will be none. And for football and table tennis, there is 4. So over here, it should be 4. So 4 minus 2 equals 2, right? And then the next one is table tennis and badminton, which is 8, right? So this should be 8. 8 minus 2, 6. Okay. So we know that this is empty. So we just ignore that. And let me remove this first. Okay. So we want to know what is the total number of participants who join only one competition only. And we understand that 24 participants join table tennis, right? Table 24. So this should be 24. So again, similar to the top, 24 minus 6 minus 2 minus 2 equals to 14. And for badminton, we have a total of 13 participants. So 13 minus 6 minus 2 equals to 5. And for football, we have 35. So 35 minus 2 minus 2 equals to 31. So they want the total number of participants who join only one competition. So that would be this, this, and this, because only they join a single competition, which is either badminton, table tennis, or football. So the answer would be 31 plus 5 plus 14, which is 15. Okay. So why am I learning? Where am I learning the theory of sets? Well, then again, it's a very wide application in the future where you can use in business, making decisions, and economics. But what you're learning now is the basics of everything, and right now, if you actually go forward into computer science or anything, you will use this, but it will be automated and you don't have to actually do it manually. I will attach an example after this, so do look at it if you are interested, but that is not included into in your examination, so you can just watch it. That's for an extra knowledge. Right, so leave a like and a subscribe, and if you have any questions, just comment below. We are going to be posting bi-weekly, so do let us know if there is any problems or questions you have. So what if you have a very large data set such as this, which is close to maybe 70 numbers, because I actually generated this number from a random generator. This set A is actually, the set 1 is actually from 0 to 70, and set 2 is a randomized number from 0 to 140, which has 70 numbers in here. So rather than actually writing it out, drawing circles and circles to drawing the Venn diagram to determine what is the intersection, one of the things is we can use the computer to help us do this thing, where I can do something like this. So I have set 1 and set 2, which I defined it as S1 and S2. So let's say I want to find the intersection between both, since there is so many numbers here that I am too lazy to check on it on my own. So I can do this. So S1 intersection S2. Alright, so that's I'm looking for the intersection between S1 and S2, which is all these data. These are all my data set for S1 and S2. And then I want to print it out, which is just a way to let me see. It's for visual aid basically. So right. Okay, so I define a new set S3. I define S3 as this is just a programming thing. You don't need to know much about, but basically I need to print S3, which is the intersection between S1 and S2, which is 1 and 2 here. Right, so I'll play it now. And so basically this is what I got from the results I got, the output that I got from the command prompt. So basically my intersection of S1 and S2 here is this list. So rather than actually drawing out the Venn diagram to determine what is the intersection between S1 and S2, I can determine the intersection using computer. So this is a way we automate this kind of system rather than doing it manually or traditionally.